Hi, in the last session, we had some overview of vector type signals and std underscore logic underscore vector data type. Now, this is important session where we will talk about the attributes of vector type signals, and I will show you that how you can use those attributes for the clean and well generalized VHDL designs. So let's start. So we discussed that the VHDL equips you with the powerful tools called as array attributes, especially useful when dealing with the std underscore logic underscore vector signals, which are essentially the array of bits. These attributes are very important and can be reused in your VHDL designs. By using these valuable details of your vector type signals, you can write the cleaner and more adaptable VHDL codes. Let's take an example of vector type signal, which is signal sig A, and this is vector type signal having 8 bits and its range is 7 down to 0. In this example, your left attribute tells the MSB of this vector, means you will get the value 7 as the left attribute. Similarly, right attribute tells the LSB, least significant bit of this vector, means you will get the value 0 as the right attribute. Same way, the length attribute of this vector will give you value 8 because it is 7 down to 0. Hence, it has total 8 bits, so length is 8. And range of this vector will give you 7 down to 0, where 7 is the leftmost bit and 0 is your rightmost bit. By leveraging these attributes, you can write more readable and the maintainable VHDL codes. Let's quickly recall the values of these array attributes here in this example, and then I will show you how you can use them in your VHDL codes. So left is 7, right is 0, length is 8, and range is 7 down to 0. Very straightforward, right? Now the table below displays that how these attributes can be applied, and you will also see their corresponding expressions. To start, consider the declaration of signal B. So signal B colon std underscore logic underscore vector, then A dash range semicolon. This example uses the range attribute to set the size of B to match whatever the range of signal A. So range of signal A is 7 down to 0. Hence the range of signal B will also be 7 down to 0. This is exactly same if you write signal sig B colon std underscore logic underscore vector 7 down to 0 semicolon. Continuing with the another example, signal C is declared as signal sig C colon std underscore logic underscore vector A dash left to A dash right semicolon. So signal A is left is 7 and signal A is right is 0. So we will have the signal B which will have the range of 7 down to 0. So this is again same if you write signal 6c colon std underscore logic underscore vector 7 down to 0 semicolon. Similarly, signal D is declared using the high and low attributes. So signal sig D colon std underscore logic underscore vector A dash high down to A dash low semicolon. This is equivalent to the signal sig D std underscore logic underscore vector 7 down to 0 semicolon. So here is a quick question for you. Do you see any benefit if you use these attributes in your VHDL codes? Let me know if you figure out any benefit of using this approach for writing your well generalized and reusable VHDL codes. If needed, you can take a small pause here. Okay, let me tell you the advantage of using these attributes in your VHDL codes with one example. So suppose today you developed a system with the 8-bit data bus line, which is supposed to process parallel 8-bit data. Now, in future requirement, you are asked to develop the same system but with the increased bandwidth. Say now you have to design your same system with the 16-bit data lines. And if you are using these attributes in your VHDL code, then it will be quick for you as you just need to change the range of your signal A. And all the other signals will sync according to the new range of signal A. But if you declare your signals like the regular approach, say 7 down to 0 or 15 down to 0, then you need to make changes for all the declared signals one by one. Let's conclude this in short that it is highly recommended to use the array attributes throughout your VHDL code. Why? Because it makes your VHDL codes more readable and adaptable. Imagine the code that automatically adjusts their vector sizes whenever you wanted to change them for your designs. And that's the power of attributes. This readability and flexibility also lead to the fewer bugs, as you are less likely to introduce errors during the modifications. Incorporating the array attributes into your VHDL design practices is a valuable strategy for writing the clean and maintainable and robust codes. While there is a broader range of VHDL attributes to explore, but we will discuss them as we progress on this course. For now, we have covered the fundamental concepts which you can use to work effectively with the data types like std underscore logic underscore vector and perform the arithmetic operations using signed and unsigned data types. Now let's talk about few more data types in VHDL similar to the std underscore logic underscore vector. VHDL offers additional data types specifically designed for the numerical operations like signed and unsigned data types. These are essentially bit vectors, similar to the std underscore logic underscore vector, but with the focus on representing the numbers. They can hold the same signal states as the std underscore logic, like logical 1, logical 0, or tri-state, etc. std underscore logic underscore vector are good in handling the databases where multiple bits are grouped together, but they are not ideal for the arithmetic operations. This is why the signed and unsigned data types comes in. So an unsigned value represents any non-negative numbers, which also includes 0 as value. For example, a counter. On the other hand, signed values can have both positive and negative numbers, which make it suitable for the calculations which involves positive or negative numbers. To work with these data types, you will need to include the numeric underscore std package in your VHDL code. Whenever your design involves the mathematical operations, signed and unsigned data type should be your preferred choice. This slide shows that how you can declare the assigned and unsigned signals in your VHDL code. This structure is very similar to the std underscore logic underscore vector declarations. VHDL offers the straightforward approach to assign the values between signals, as long as the signals share the same data types and size. I mean the array length for vectors, where you can perform a direct assignment. So signal X is assigned to signal Y using the assignment operator. This assignment is fundamental concept for the data flow within your VHDL designs. In the next session, we will be talking about the another most important data type, which is integer. And I will tell you about the best practices of using integers in your VHDL codes. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for the regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.